Algebra 1, lesson 111 is a favorite of mine. It's called Solving Using Permutations. Permutation is where you see things called factorials, where you've got, let's say if there's 5 objects and we're ordering them, then you end up with 5 with an exclamation point next to it. That's called a factorial. Permutations involve arranging objects, events, whatever, when the order does matter. So this is different than when we used the fundamental counting principle and tree diagrams, where it's just arrange them in all the ways possible. In this case, it's how many different combinations are there, and BA is different than AB. That's what I'm talking about. So, whereas before, as long as they were paired, that counted, so you'd have less options. Now, since we consider A being first as a separate possibility, instead of only 3 options, you have 6, what we call permutations. All right? Let's listen to what they've got.
A student wants to find all the ways to arrange a circle, a square, and a triangle in a line. The different arrangements are called permutations. Click the figures to see some arrangements.
Because if it wasn't a permutation, it's the same 3 shapes, it wouldn't really matter. But since order does matter, it's the ways they can order the shapes. All of these are separate permutations.
One way to arrange the figures is by placing the circle first, then the square, and the triangle. Another way is to switch the order of the triangle and the square. Each order shows a unique permutation.
Okay.
Drag the figures to show different ways you can arrange the triangle, square, and circle.
Notice they've already got 2 rows done for us. So I'm going to put my circle in the middle, triangle, square. Let's put the triangle and square in the other order. Then I'll put the circle at the end, triangle, square, and in the other order. And I don't think there's any other ways.
How many permutations are there?
Basically, how many rows then are counted up, including the 2 they did for us? I count 6. Permutations, we call it, because order matters. Car dealership wants to find all the possible ways to display all the orders for 3 cars, the red, the blue, and the white car. The table shows 5 out of the 6. Red first twice, red second twice, but I don't see red third twice. So that's my first clue. Red needs to be third, and so there you go. That's the 6th one. The white being first, because that's only happening once. The red being third, which had only been happening once. And then the blue in the middle, which had only happened once so far. Gardener has 4 new roses to plant. The table shows the different ways to plant. Rose red, white, yellow, and orange, because you can have different color roses. They're not just red. So how many different ways could he plant? Oh, goodness gracious. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Looks like 24. Okay. This is the last one that they're going to do on here for us, and then I'm going to take us to Paint to work on one on our own. We've got 3 people. 3. They are being elected president, vice president, and secretary. So it matters if Linda is first, which is the president spot, or if Jose is, or if Larry is. So order matters. These are permutations. It's a factorial of 3. A factorial of 3 means we solve like this. We go 3, and then we go n minus 1 times n minus 1. So when there's only 3 people, when order matters, just like when we've started, we found that ends up being 6 different arrangements. 3 times 2 times 1. It's more interesting when you start getting higher numbers than that. Let's try this when it gets just a little more complicated. Take a look at example 3. Specifically letter B. It says a total of 6 classes are competing to see who can collect the most recyclables. Page 757. And how many different ways can the classes finish in just first and second? What makes this a little more interesting is that we've got 6 classes, but only 2 spots, first and second. And they're asking how many different ways can all these classes be arranged into these 2 spots. The way you do this is you start with your normal permutation, your factorial 6 at the top, and then you divide that by 6 factorial again. Actually, no. 6 without the factorial. 6 minus how many spots you're picking. And that's 2. Right? 1, 2. They call that R in the formula in the box on page 756. So 6 minus 2 is 4. 6 factorial, again, means 6 times 5 times 4 times 3 times 2. And the 1 never really makes a difference, does it? So 30 times 4 is 120. Times 3 is 360. Times 2, 720. I forgot that there's a factorial right here. So that's going to make our number a lot smaller. That means 4 factorial on the bottom, which is 4 times 3 times 2, which is 24. So 720 divided by 24, which means we no longer have quite that many. "24 fits into 72 twice? No, 3 times. Evenly, doesn't it? Whoopsie. Because 24 times 3, yep, is 72. So 3, and then it's coming out even. So you got 30 different ways. Still a lot. Still a lot. Why don't you do A, C, D, E, F? A, C, D, E, F. And remember, for letters E and F, be aware you might have to use the formula, what you're finding, that permutation, and then subtract how many different, that's this one, spots if there's less than the full amount. And then don't forget that factorial there. That was my mistake.